I'm Stefan Immler, an astrophysicist at NASA's Goddard Space Flight Center. I'd like to take you on a tour of two nearby galaxies in our cosmic neighborhood, the Large and Small Magellanic Clouds, as captured in ultraviolet light by NASA's SWIFT satellite. These images are the highest resolution wide-field surveys of the galaxies at ultraviolet wavelength. Both of these galaxies are less than 200,000 light-years away, and each contains a few 100 million stars like our Sun. If you live or travel to the southern hemisphere, you'll see both of these galaxies as faint cloudy patches in the night sky. Both galaxies orbit our own as well as each other. Of the two, the LMC is physically larger and nearer to us than the SMC. Their messy shapes are a product of gravitational interactions between them, tidal forces from the much bigger Milky Way, and internal processes like star formation. In visible light, we see a mix of sun-like stars, along with pink patches that mark star formation regions, where hydrogen gas is set aglow by the light of young stars. These are especially prominent in the LMC. Viewed at higher energies in the UV, the LMC looks very different. This wavelength blocks out the older stars, mostly showing those less than 500 million years old. These galaxies are relatively small, but they're also very close to us. This means they appear much larger than the field of view of Swift's telescope, so we had to take many different observations and stitch them together. Swift had to image 172 separate fields in 2,200 short snapshots to take in the whole galaxy. The LMC's most striking feature is the dramatic Tarantula Nebula. This is the most active star factory in any of the dozens of galaxies in the local group, which includes the Milky Way and Andromeda. Thousands of stars form each year within cool, dark molecular clouds. Once they start shining, they blow off their birth cloud with powerful outflows called stellar winds. These winds, in turn, sculpt the gases into the Tarantula Nebula's spider-like shape. One star here, named R136A1, is one of the most massive known, weighing more than 260 times the Sun. The LMC holds more than 1,000 star clusters formed during previous rounds of star formation. We mostly see hot, young, luminous stars, plus a few stars in exotic stages as they near stellar death. Wherever there are hot, young and massive stars, there are also supernovae. In 1987, the closest stellar explosion in more than 400 years occurred in the outskirts of the Tarantula Nebula. Even 26 years later, the afterglow of the explosion remains detectable in the ultraviolet. All told, the new Swift mosaics reveal about 1 million objects in the LMC and about 250,000 objects in the smaller, less massive and more distant SMC. For this mosaic of the SMC, Swift imaged about 50 fields and took 656 snapshots. One interesting feature is the massive young star cluster NGC 346. It contains the SMC's brightest star, HD 5980, a triple star system where all members are among the most luminous stars known. The intense light and strong outflows from these stars mold the surrounding gas into a shape resembling a cobweb. The Swift UV mosaics allow us to study the evolution of young stars in the LMC and SMC all in one view. That's impossible for us to do for our own galaxy, because we're inside it. The images give us a panoramic window into how stars are born, evolve and die across two complete galaxies. That gives us fresh insight into the many ways stars transform the universe into what we see around us today.